We now want to find all x such that this equation holds. Now, this equation, it's easy to fall into a trap here. And it's exactly the trap I've just talked about. So what's not true is the following. So kind of the wrong approach before I do anything. The wrong approach is to think, well, I can see a factor of x in each side. So I can see a factor of x in each side. So that means I can cancel it off. So after cancelling x, we get, what do we get? We would get x plus 1 is equal to 4. So x is equal to 3. What's the mistake? The mistake is we cannot cancel x if it's equal to 0. Okay, you cannot cancel off something if it's equal to 0. So we lose that potential. So a safer way to do this is to try to rearrange it and write it as a product of two things, where the product is equal to 0. Then we can apply the zero product property. So let's do that instead. Okay, so correct. Well, x times x plus 1 is equal to 4x. What does this guarantee? Well, let's multiply out. Let's use the distributive law on the left-hand side first of all. Get this. Okay, so then let's, if you want, add minus 4x to both sides and simplify. So this would give me x squared minus 3x is equal to 0. And now I can pull off a kind of a similar trick as I did in the exercise we've just seen, in that I can factor out an x here, and that would give me x minus 3 is equal to 0. So this now is a product of two different things. The only way it can be equal to 0 is if either one is 0 or the other is 0. So this implies that x is equal to 0, or x minus 3 is equal to 0, which of course finally implies x is equal to 0, or x is equal to 3, adding 3 to both sides of this equation. So the crucial thing really is basic manipulation of the equality using our laws of algebra, and then at this point invoking the zero product property. Now you could try doing this with the cancellation law, but you'd have to break the entire problem into two pieces. You'd have to break it into the scenario where x is equal to 0 and the scenario where x is not equal to 0. If you assume x is not equal to 0, you do have the cancellation law and you would get the solution x equals 3. But then you've got to go back to the start and be like, well, what happens if x is equal to 0? Does it work? Thankfully, it's pretty obvious to see that x is equal to 0 is a solution, but it's more of a difficult chain of logic, I think, because you've broken the problem up into two kind of distinct cases, which is often necessary, but in this case it's not. It's cleaner to do it, I think, with the zero product property. Both are fine. It's just there's a danger of using the cancellation law blindly without realizing, sure, x has to be non-zero for it to apply.